If you trace your family tree back a few generations, the numbers explode. You have 2 parents, 4 grandparents, 8 great-grandparents. Keep going back just a few centuries, and the math suggests your lineage should expand into thousands of people. It feels like an ever-widening web, a vast network of lives branching out across history, making your existence feel almost inevitable. But if you could pull the camera back even further, past the invention of writing, past the dawn of agriculture, past the final ice age, the web stops expanding. Instead, it begins to shrink. If you travel back roughly 70,000 years, the branches of the human family tree don't just narrow, they nearly vanish. The sprawling forest of human ancestry chokes down to a single, terrifyingly thin thread. Every single person alive today, every scientist, every politician, every stranger you pass on the street, and everyone you have ever loved shares the exact same tiny handful of ancestors who happen to be standing on the planet at that exact moment. We look at our world today, with our concrete cities, global networks, and billions of people, and we assume that humanity was always destined to dominate the Earth. We view our dominance as a foregone conclusion, but the genetic code written inside your cells tells a completely different story. It tells the story of a time when the entire human experiment was reduced to a few thousand terrified individuals hiding in a darkening world. A time when our species didn't just face hardship, we came within a breath of total, permanent erasure. To understand how we reached that edge, you have to look at what the world looked like 70,000 years ago. It was not a world we would recognize. There were no cities, no roads, no monuments. Earth was a wild, untamed wilderness, and Homo sapiens were just one of several human species walking the planet. We shared the globe with Neanderthals in Europe and Denisovans in Asia. Our ancestors didn't have the upper hand. They didn't have agriculture to guarantee food or medicine to cure disease. They lived in small nomadic bands, deeply attuned to the rhythms of the earth, but entirely at its mercy. They were hunter-gatherers, moving from place to place, following water, game, and seasonal plants. In this world, survival was already a daily negotiation. Life was brief, fragile, and intensely local. If a river dried up, a band died. If a winter lasted too long, a lineage ended. Humanity was already spread thin across the landscape, living in isolated pockets. We were not the masters of the planet. We were just another medium-sized mammal trying to survive the night. We were already vulnerable. And then, the Earth opened up. On the island of Sumatra, in what is now Indonesia, there was a mountain called Toba. To anyone looking at it 70,000 years ago, it might have seemed like an ordinary part of the landscape, but beneath the surface a massive chamber of magma had been building pressure for hundreds of thousands of years. It was a supervolcano, a geological monster capable of an event so violent it defies human scale. When Toba finally blew, it did not just erupt. It exploded with the force of millions of nuclear weapons. It tore a hole in the earth so large that the collapsed crater left behind is now a lake big enough to be seen from space. The immediate aftermath was apocalyptic. Billions of tons of ash, rock, and toxic gases were hurled straight into the stratosphere. Punching through the atmosphere and spreading across the globe, the blast sent a shockwave through the natural world that changed everything overnight. In the regions closest to the blast, columns of superheated ash and gas rushed across the landscape, burying everything under hundreds of feet of volcanic debris. But the true danger wasn't the immediate blast. It was what happened when the ash reached the sky. The immense cloud of sulfur dioxide and ash didn't dissipate. It caught the high-altitude winds and wrapped itself around the entire planet, acting like a giant, dirty mirror. It reflected the sun's rays back out into space, plunging the Earth into a sudden, artificial twilight. The sun didn't shine the way it used to. Day after day, the sky remained a bruised, dull gray. Across the globe, temperatures plummeted. In some regions, the average temperature dropped by over 10 degrees Celsius. Forests withered. Grasslands dried up. The monsoons failed. A brutal, unexpected volcanic winter settled over the Earth, and it didn't last for a few weeks or a few months. It lasted for years. For our ancestors living thousands of miles away in Africa and across Asia, the world simply broke. They had no idea what a supervolcano was. They didn't know that an island thousands of miles away had exploded. All they knew was that the plants they relied on were dying. The animals they hunted were disappearing. The water sources were freezing over or turning toxic from ashfall. The environment they had spent millennia adapting to had changed completely in the span of a single season. This is where the story shifts from a geological disaster to a human tragedy. For a long time, scientists had no idea this crisis had occurred. They stumbled into it backward, not by looking at rocks, but by looking at us. In the late 20th century, geneticists began mapping the human genome, looking at the DNA of people from all over the world. They expected to find an immense amount of genetic diversity. After all, humans live in every corner of the globe, look vastly different, and have adapted to entirely different climates. But when the data came in, the scientists were stunned. Human beings are shockingly, remarkably identical. If you take a single group of chimpanzees from a single forest in Central Africa, you will find more genetic diversity among them than you will find across all 8 billion humans alive on Earth today. Two people from opposite sides of the planet are genetically closer to each other than to chimpanzees, living on opposite sides of a river. This lack of diversity is a massive clue. In biology, a lack of genetic variation usually means only one thing: a population bottleneck. It means that at some point in our past, the human population didn't just decline, it collapsed. The genetic pipeline was squeezed so tightly that almost all variation was wiped out. When researchers calculated when this collapse happened, the timeline pointed directly to a window around 70,000 years ago. The genetic models suggested that the global population of breeding Homo sapiens plummeted from perhaps 100,000 down to a few thousand individuals. Some estimates suggest there were only a few hundred breeding pairs left alive on the entire planet. Think about that number, a few thousand people. That is not a city, that is not a town. That is a crowd at a local sporting event. That is the entire population of our species scattered across vast distances, struggling to find food in a world where the sun had failed. If a disease had swept through those remaining groups, if a few consecutive winters had been slightly harsher, if luck had swung just a fraction of an inch in the wrong direction, the human story would have ended right there. Homo sapiens would be nothing more than a strange, transient fossil layer in the earth, a biological dead end that almost made it we were a single bad afternoon away from never existing. Like all great scientific stories, however, the reality is complicated, and the debate is far from settled. In the years since the Toba bottleneck theory was first proposed, teams of archaeologists and geologists have dug deeper into the Earth, looking for direct evidence of how humans handled the ash, and what they found complicated the narrative. In parts of India and South Africa, archaeologists discovered stone tools directly beneath the layers of Toba ash, and right above them, they found more stone tools. The people there didn't seem to disappear. In some locations, the tools even became more sophisticated after the eruption, suggesting that, instead of dying out, some human groups adapted, innovated, and fought their way through the crisis. Other climate scientists argue that the volcanic winter, while severe, might not have been equally devastating everywhere. Some pockets of the world, particularly coastal regions with abundant marine life, might have acted as safe havens, refuges where the climate remained stable enough for humans to scrape by. This leaves science in a fascinating place. Was it truly Mount Toba that caused the great human collapse? Or was the genetic bottleneck the result of a longer, slower climate shift that was already underway? Some scientists believe the bottleneck wasn't a sudden event at all, but rather the reflection of a small population of humans leaving Africa and slowly expanding, carrying only a fraction of our original genetic diversity with them. The debate continues, and the exact sequence of events remains locked in the deep past. But notice what happens to our perspective when we look at this debate closely. The mystery doesn't make the story less unsettling, it makes it more profound. Because whether the culprit was a single supervolcano in Indonesia, a prolonged ice age, or a series of brutal environmental crises, the underlying truth, written in our DNA, remains unchanged. Our ancestors did pass through a needle's eye. We know for a fact that our genetic diversity is dangerously low. We know that at some point in our deep history, our numbers were reduced to a fragile remnant. The true revelation of this story is not about the destructive power of a volcano. The true revelation is the realization of just how fragile our existence has always been. We tend to look at the modern world or technology, our art, our laws, our grand ambitions, and we feel permanent. We look at our history as a steady, inevitable march from the cave to the stars. We treat our survival as a given. But it was never a given. Every nation, every language, every piece of music ever composed, and every technology we use today emerged from a species that once stood on the absolute brink of nothingness. Civilization didn't grow out of an unstoppable, triumphant empire. It grew out of a tiny group of survivors who managed to keep a fire burning when the sky turned black. When you look at humanity through this lens, the world begins to look very different. We are not the masters of an inevitable destiny. We are the descendants of an impossible streak of luck. Every single human being alive today is part of an unbroken chain of survivors that stretches back through unimaginable cataclysms, ice ages, and disasters. Every one of your ancestors managed to find food, avoid predators, endure the cold, and pass the spark of life to the next generation, even when the odds were entirely against them. We often think of ourselves as powerful because of what we have built, but perhaps our true power lies in the sheer improbability of our survival. We are a species that nearly didn't make it, and every day we spend on this planet breathing the air and looking at the stars is not a guarantee. It is a privileged one for us by a few thousand ancestors who refused to die in the dark.